So let's talk about functions. So what is a function? So let's say you have something, right? Let's say you have an input, right? And then you do something with the input, right? We don't know what we do. And then we get an output. So let's talk in mathematical terms. So let's say I give you the number 6, for example, right? I give you 6, you do something to it, and then you give me 15 back. You could have done many things to it. You could have multiplied it by 2 and added 3. You could have multiplied it by 3 and subtracted 3. We don't know what you did. That's what the function is. The function tells us what you did to the input. So the function tells us what happened to the input. And we'll do some examples of this so it makes more sense. What happened to the input, and it also gives us the output. So let's say we had a function, let's call it f of x. That means the function on x. Let's say that's equal to 2x plus 8 minus x squared, right? Let's say that's our function. That means if I give it a value of 3 for x, so let's say f of 3, now 3 is the input, right? So what does the function do? The function multiplies 3 by 2, adds 8 to it, and then subtracts 3 squared from it. So we have 2 times 3 plus 8 minus 3 squared is 9. That is 6 plus 8, 14, minus 9, which is 5. So you get 5 as our answer. So if the input is 3, and then if this is the function, then our output is 5. That's all a function does. You give it an input, it does something to it, and gives you an output. So let's say we had two functions. So let's say we had f of x now is equal to 2x plus 1. And then we had g of x is equal to 3x plus 3. So now we have two functions. So what if you wanted to find, let's say we wanted to find g of 2. So if you want to put 2 in here, what we get is the output. But then let's say whatever the output we get over there, we wanted to apply f to that. So we do f of the g of 2. So we first put 2 in here, we get an output, and then that output, we put it back into f right here, and that's our new input for f. And then we get another output, and that's our final output. So when you're writing it as fg of 2, this is very different from gf of 2. This means not equal to, because the g of f of 2 would mean you put 2 in f first, you get an output, so you get 2 times 2, 4, plus 1, 5. You get that output, and then you put that into g, and then you do 3 times 5, 15, plus 3, which is 18. So gf of 2 would give you 18. You put 2 into f first. But fg of 2 means you're putting 2 into g first, so that's 3 times 2, 6, plus 3, which is 9. And then you put 9 into the input for f right here, and you get 2 times 9, 18, plus 1, which is 19. So you can see f of g and g of f are not the same thing. So in general, g f of x is not equal to f g of x. And of course that makes sense because you're literally doing two different things. You're getting a different output here, and then you're using that as the input here, and you're getting a different output here and using that as an input for a different function. So we have that. Now let's go back to our simple example. So let's say we had g of 3, right? So g of 3 would be, you put 3 in here, so you have 3 times 3 plus 3, which is 12. So you get 12. So now let's say for some reason I gave you 12 and I wanted to get back to 3. How would you do that? Well, what we would have to do is find the function. We have to find another function. So this is new function. And this is called the inverse of g because it inverts whatever you give it. It's because before we give it an input and give us an output, now we want to give it that output and we hope that it gives us back this input. So if we say g prime of x is equal to, and now this is question mark because we need to find it. So g of x is equal to 3x plus 3. So this is the trick to do it. So let g of x equal y, okay? Let's call g of x y because it's simpler to work with. So now we have y is equal to, well, we have 3x plus 3. 3x plus 3. Now what you do is, you do something like this. So you see wherever the x is, right? You replace the x with a y, and you replace the y with an x. So what this means is that you make it, instead of y over here, you have x is equal to 3y plus 3. And now what you want to do is you want to get y by itself. So you see over here you had y by itself in terms of x. Now you have x by itself in terms of y. But now you want to go back to having y in terms of x. So you rearrange this equation right here. So what can you do? You can subtract by 3 on both sides. So now you have x minus 3 is equal to 3y. Then you can divide by 3 on both sides. So you have y is equal to x minus 3 divided by 3. And let's see if it works. So that means, so y, remember, is now g inverse of x, right? So this is the first y, that's the g of x. We did that. And now we replaced y with x. So now this y is for the g inverse of x. So g inverse of x is equal to x minus 3 or 3. The important part is not get confused. This y is not g of x anymore. We can give it another notation. Let's call this y tilde x tilde. This is just like just for us to know that this is a different y and a different x, because you don't want to get it confused with this y over here. Different x, different y, and this is that x. So y tilde is equal to g inverse of x. And let's see if it works. So if we put 12 in here, we should get back 3, right? So if we get 12 minus 3, that's 9, divided by 3, which is 3. And that's what we wanted. We wanted the 3 right here. Let's try another number. So if you had g of, let's say, 7, right? That is 7 times 3, 21, plus 3, which is 24. And let's try g inverse of 24. Well, that's 24 minus 3, that's 21 divided by 3, which is 7. So that's equal to 7. And that's how you find inverse functions. So we have done functions, the basic introduction to functions. We've done composite functions. Composite just means like compose two functions. This means put two functions together, like f and g. And then we've done inverse functions, which give us back. An inverse function is when you give it the output from the original function, it will give you back the input from the original function. So that's what it does. And let's do some examples so it makes more sense to us. So let's do this question right here. So we have four functions in fact. We have f of x is equal to 2x minus 1. We have g of x is equal to 3x plus 2. We have h of x is equal to 1 over x. X is not equal to 0. And we have j of x is equal to x squared. So the first question says find j of minus 1. That means if you put minus 1 as the input, then what's the output? Well, you just put minus 1 in here. So j of minus 1 is equal to minus 1 all squared. And that is equal to minus 1 times minus 1 is positive 1. So you have 1 as your answer. That was pretty simple. Find x when f of x plus g of x equals 0. So what's f of x? Well, that's given to us. That's 2x minus 1. So you have 2x minus 1 plus g of x. G of x is 3x plus 2. Plus 3x plus 2. And this is equal to 0. So now we have to find the value of x that satisfies this equation. Well, you can remove the brackets and you can add this right here. So you have 2x plus 3x is 5x. You have minus 1 plus positive 2 is positive 1. And that's still equal to 0. You can bring the 1 to the other side, so you're left with 5x is equal to negative 1. And then x is equal to negative 1 over 5, or negative 0.2. So negative 0.2 is our answer for that. Find g of x, giving the answer in its simplest form. So let's find g of the g of x. So we have g of x is 3x plus 2. Let's write that again. Is equal to 3x plus 2. And now what we want to do is, whatever the answer we get over here, we want to put it back into g of x again. But this is not the same as g of x squared. So you have to make sure you remember this. g of x is not equal to g of x all squared. And we'll do both and show you why it's true. We need to find g of x first, so let's do that. So that's like putting g of the g of x. Well, the g of x is 3x plus 2, we have that. So that's putting g for 3x plus 2. So wherever we had an x in the g of x, we put 3x plus 2 back instead of that x. So it sounds like a lot of words, but all it is saying is that g of x is equal to, well, you have 3 times, instead of the x now, you have 3x plus 2. So you have 3x plus 2. And then that's done, and then plus 2. That's just the plus 2 by itself. So this is equal to 9x. 3 times 2 is 6, and then plus 2 is 8. So 9x plus 8. That's g of x. And this is not equal to g of x all squared, because that would mean you're squaring 3x plus 2. So that's saying 3x plus 2 all squared. And this would give us 9x squared plus 12x plus 4. You just open the brackets. And this is not equal to 9x plus 8, because if you put in an input for this, you'll get a very different answer if you put an input right here. So make sure you get that right. G of x is not equal to g of x squared. Same with f, same with h or j. It's not the same thing. Sometimes it works, but most of the times, 99% of the times, they won't be the same thing. Find h f of x plus g h of x, giving you answers as a single fraction in its simplest form. So now we're composing two functions, and we'll have a fraction, and we have to simplify it. So h f of x first. So f of x is 2x minus 1. So f of x is equal to 2x minus 1. And we want to find h f of x, which means, and we know h of x is equal to 1 over x, right? So that means instead of the x right here, we put f of x, which is 2x minus 1. So h f of x is equal to 1 over 2x minus 1. So we have that on the side. And then we want to find g h of x. So g of x is equal to 3x plus 2. And we want to find g h of x. So h of x is 1 over x. So instead of the x over here, we put 1 over x. So we have 3 times 1 over x plus 2. Well, and now you want to add these up. So we have 1 over 2x minus 1 plus 3 over x plus 2. Because 3 times 1 over x is 3 over x. Well, what can we do? We can multiply everything by 2x minus 1 and x. So that is equal to, if you multiply everything by 2x minus 1 times x divided by 2x minus 1 times x, that's like multiplying by 1. That doesn't change anything, right? So let's do that. So over here, if you multiply by 2x minus 1 and x, the 2x minus 1s would cancel out. You will be left with just x. So you would have x plus 3 times, well, if you multiply by 2x minus 1 times x, the x's would cancel out. You'll be left with 2x minus 1. And then here plus 2, and then this whole thing. So 2x minus 1 times x is 2x squared minus x. And then this is all divided by 2x minus 1 times x. This is all just simple algebraic manipulation. And then this is equal to, well, you have x plus 6x minus 2x. So that's 5x. Just opening the brackets. So x plus 6x, 7x, plus minus 2x is 5x. And then 3 times negative 1 is negative 3. So you have negative 3. And then you have 2 times 2x squared, so plus 4x squared. And then all of that is divided by x times 2x minus 1. Can we simplify this further? Let's see, can you factorize this? Let's see, we have 4x squared plus 5x minus 3. So we have 4x squared plus 5x minus 3 divided by x 2x minus 1. Can we factorize it? Let's see. So if we did 2x and then 2x, if we did minus 1 and plus 3, what would we get? We get minus 2x plus 6x. No, I don't think we can factor. I think that is how we should leave it in the final form. So we're left with 4x squared plus 5x minus 3, all divided by x 2x minus 1. Okay, let's do part E. So when p times p of x, or p composed with p of x, is equal to x, p of x is a function such that the p inverse of x is equal to p of x. Draw a ring around the function that has this property. So it looks very confusing, but it's only 1 point, so it can't be that difficult. So that's saying that, oh, this is an interesting one. This is saying that the inverse of the function is equal to the function itself. So remember, we were looking, when we were doing our working out right here, we were looking at different functions, and we were finding inverse functions, right? And we were trying to say that what number, if I input a number into our original function, you get an output. And if I put that output into the inverse function, I want to get the same input. And we're going to do the same thing here. So let's try let's try put some numbers in. So let's choose our number to be, let's choose x equals 3, because we can choose anything, but let's choose x equals 3. We can't choose 0, we can choose anything but 0, because that won't work. So if x is equal to 3, well, we would do 2 times 3 minus 1, so that's 6 minus 1, that's 5. And what this question is saying is if you put 5 back into this function here, we should get 3. So let's try. So you get 2 times 5, 10, minus 1 is 9. So 5 is not equal to 9. So, and 5 is not equal to 9, and we wanted 3 anyways. 5 is not equal to 3. So we don't care about this. So f can't be correct. Let's try it with g of x, 3x plus 2. So we do 3 times 3, 9, plus 2 is 11. Put 11 back into this. So 11 times 3 is 33, plus 2 is 35. So you get 35. And of course, that's not equal to 3, so we don't care. Let's try this one. This one looks interesting. 1 over x. So let's put 1 over 3 into our function. Let's put 3 into our function to get 1 over 3. So we get 1 over 3 right here. And if we put 1 over 3 back into here, we would get 1 divided by 1 over 3, which is positive 3. And that is our initial input. We put 3 in, we got 1 over 3. Then we put 1 over 3 back in, and we got 3. So that means that the inverse of this function is actually equal to the function itself. So this is such a function that if you take the inverse of it, it's going to be 1 over x. Because you just saw, if you put an input in, you get an output. You put the output back into the same function, and you get the same input. Because over here you can see that we have to find a different function. The g inverse of x looks very different from the g of x. Well, not very different, but a little bit different. But here, h of x and h inverse of x are the same. Let's just make sure this is the only function. So put 3 into j right here, so you get 3 squared, so that's 9. And you put 9 back in, so you get 9 squared, which is 81. And 81 is not equal to 3, so we don't care about this. This is not the right function, g is not the right function, and h is the right function. So yeah, that's all you need to know about functions. So we've learned what a function is. So let's do it right here. So we've learned what a function is. We've done composition of functions. Composition. We've done inverse functions. And we've done solving equations with functions, because we did solve this equation right here. Solve equations. We solved an equation over here. Find x when f of x plus g of x equals 0. And we got a value for x. So yeah, that's interesting. But one thing I do want to point out is just remember this right here, because this is a mistake that's very common. And please make sure that you don't make this mistake, because f of x, g of x is not equal to g of x all squared. Those are two very different things. So yeah, that's all about functions. I hope you learned something. If you did, please like, comment, subscribe, and share this video, and let me know what you want to see in future videos.